Hello guys, welcome to the machine design world. This is Coil and today we are going to see design of spring. In last video, we have seen the introduction of the spring. Links of the same is provided in the description. Today we will start the design, that is numericals based on design of springs. Okay, so there are two approaches, static and dynamics. Today we will seek static approach. So let's start with the static approach. So there is a little difference between static approach and dynamic approach, which we have seen earlier. For static approach we use shear stress factor, and for dynamic approach, that is fatigue loading, we use Walls factor. So in static approach you will be having only one load and one deflection point, okay, where in dynamic approach we will having varying load. So let's start with the first sum. Sum reads, a helical compression spring is subjected to a force of 500 Newton. So what is given? Force 500 Newton with a corresponding deflection of 20 mm. So y is equal to 20 mm. Actually I am using y term. In PSG they are using y as a notation. Then the spring index is 6. C is equal to 6. Sometimes spring index is not given, so you know that spring index varies from 4 to 12. You can consider any, but try to use 5 or 6. The spring material load, the spring material had UTS of 1000 Newton per mm square. So ultimate tensile strength is given as 1000 Newton per mm square, right? The permissible shear stress for the spring wire is 50% of the UTS. So they are saying sigma permissible is equal to 50%, that is 0.5 of UTS. So it is nothing but 500 Newton per mm square. Then if the modulus of rigidity, that is G, 8 into 10 raised to 3 Newton per mm square, find all these value. The wire dia D, the mean dia capital D, number of active turns, and the free length LF, the pitch P, helix angle phi. So these all values we have to find. So first of all we will see this tau permissible. It is given as 0.5 into UTS, and some problems this term is not given. Okay, in this problem it is given, but some problems the sigma permissible is not given, only UTS is given in the terms of sigma u. Okay, in the terms of sigma u. Okay, in that case you have to use PSG. You know the design of spring, PSG page number, it from PSG 7.100 to 7.105, right? So in 7.102 you will find this table where you can have static approach for varying load. Okay, so we are having static approach. Now if it is not given, sigma permissible, in that case just choose average service. It is classification, number of cycle. If number of cycle is given, let's guess 10 raised to 5 number of cycle is given. So 10 raised to 5 means this is 10 raised to 4, 10 raised to 6, and 10 raised to 4, 10 raised to 6. So in that case you have to use 10 raised to 5 lies between here, so average service. Okay, it is more than 10 raised to 6, then you can go for service, severe service, but most probably it is between 10 raised to 5, 10 raised to, they give 10 raised to 5 only. If it is not given, then consider average service. If this term number of cycle is not given, consider average service and go for 0.324 into sigma u. Now we are having 0.5 into sigma u, so we will use that term only. If it is not given, then 0.324 into sigma u. Okay, so we got sigma permissible. Now we will move for the wire diameter. The first term is wire diameter. The wire diameter. Now we know which approach to use. Static approach. For static approach we use KSH, that is shear stress factor, and it is given as 1 minus 0.5 upon C. Okay, so now we're having the value of C, that is 6. So you will get 1.083. If we having dynamic approach, then we will go for KW, okay, and sorry, KS, and that value is given on PSG 7.100. For this KSH, this formula is not given in PH. Alright, you have to remember this formula. Now we having the value of KSH, we should go for shear stress induced. Shear stress induced. So formula for shear stress induced is tau is equal to, again we'll go for PSG, and in PSG 7.100 you will find this formula. This is tau, and tau is a shear stress. Tau formula, we having two formulas. You can use any formula whichever you require. I always use this formula and go for this formula. Alright, go for this formula because here D is unknown. If you know the D, then you can go for this formula. So we'll go for this formula. It reads, so I use this formula from PSG 7.100. Okay, here it is written KS, but we are having static approach, that's why we are using KSH. So now we know the tau value. Tau permissible is 500. So 500 is equal to KSH, we already found out, 1.083 into 8. P we know 500 Newton, C is 6, pi into D square. So we can find D from here. After calculation, you will get 4.068 mm. Okay, but you have to select standard diameter. Okay, and standard diameter is given on PSG 7.105. So this is list of standard diameter. So now we having 4.068. So see 4.068. So it is 4.0. So you have to take next value, that is 4.5. So whenever you having value like 4.1, you should go for the next value. Don't go for 4.0. Next value is 4.5. So standard diameter, selecting standard diameter from PSG, selecting standard dia from PSG 7.105, or you can directly write D is equal to 4.5 mm and PSG 7.105. Don't have to write this whole sentence. All right, now we'll find capital D, that is mean coil dia. So second is there was mean coil dia. So we'll go for mean coil dia. Mean coil dia. Okay, capital D. We know that C is equal to capital D by small d. So implies D is equal to C into small d is equal to C we know 6, D we know 4.5 is equal to 27. Okay, that is easy. Okay, quite easy. So now we will move to the next, that is number of active turns. Okay, so number of active turns. All right, number of active turns. So we're having one more formula on PSG 7.100, this deflection formula, in terms of you can take this. Now you having capital D, you can use this formula or you can go for this formula. Both formulas are the same. Here is d cube upon d raised to 4. So what is d cube upon d cube? It is c cube. So they have using c cube over here and remaining d over here. So they both are the same formula. You can use any formula. Y is a deflection which is given in problem itself. Okay, so y is equal to 8 p d cube n upon g d raised to 4. So this is from PSG 7.100. Now we know y value, that is 20, is equal to 8 into p 500. D we found out 27 cube into n we need to find upon g. G is given in question itself, 8 into 10 raised to 4, and d is 4.5 raised to 4. So from this you can find n and you will get 8.33. Okay, but n is a number of active turn and it should be perfect number, so equivalent to 9. Alright, now if you have seen the last video, then you will come to you must have understood about the ends, type of end. Now we have to select the type of end. Alright, so which type of end to be selected? We having 4. You can use any type of end among these 4, but there is one advantage squared end and ground end has over 3 yields. The load on the helical compression spring can be maintained axial by using square and ground end. So this is one advantage which square and ground end have. That's why I'm just using square and ground end. Okay, for square and ground end we're having total coils is n plus 2. Okay, so assuming square and ground ends. Okay, so total number of coil n dash is equal to n plus 2, and that is nothing but 11. This is from PSG 7.101. Right, hopefully you are understanding the problem. So now we can go for calculating the length of the spring. So first we will find solid length. Okay, solid length ls. It is given again, solid length is given in the same table. This is we found out the total number of coil. Here it is given solid length ls, and for it is for square and ground it is d into n plus 2 into d. Okay, dn plus 2d. So ls is equal to dn plus 2d. So d is 4.5, n is 9 plus 2 into d is 4.5. See, this is not n dash, you can't use this is n. Okay, so you will get ls as 49.5 mm. Now free length LF. Now let's understand this free length first. Okay, so when there is no load is acting on compression spring, the length of the spring is free length. When it is like maximum load is acting and it is having like coils are touching each other, then it is solid length, right? So this will be maximum displacement, y max. Okay, so LF will be ls plus maximum deflection. So after maximum deflection, these coils will touch each other and we will get ls. So we can say that LF is equal to ls plus y max. Okay, but this when we having ls, we consider ls, there is always a clearance of 1 mm between every coil, or there is some clearance between every coil. So we have to consider that clearance, and we consider that clearance as 0.15 of y max. Okay, so LF is solid length plus maximum deflection plus this term is nothing but clearance, and it is equal to 0.5 of deflection. Right, so we're having LS as 49.5 plus Ymax as 20 plus 0.15 into 20, so you will have 72.5. Alright, so understood this concept, right? So I'm moving ahead. Now what we have to find? We got this pitch and helix. Pitch and helix angle. So let's start with pitch. Okay, there is one formula for pitch. We have already seen that. So we have already seen one formula over here for solid length. Now we're having one more formula for free length. So LF is for square and ground nut is PN plus 2D. Okay, this is from PSG 7.101. So now we know LF 72.5 is equal to pitch. We want to find, and we know number of active coil N 9, 2 into 4.5. From this you will get the value of pitch as 7.05. Okay, so now we are done with pitch, so we'll go for helix angle. Helix angle formula we have seen in screw jack. Okay, the same formula, phi is equal to tan inverse P upon pi d. This formula we have seen in screw jack. So our power screw, it is equal to tan inverse P is something 7.05 upon pi into 27, and you will get value as 4.75. Okay, so I think we got all the values required. So this is static approach. It is easy. When we will get for dynamic approach, it is little tough. So we'll see one more problem of static approach. Let's move to the next question. And question reads: a closed coil spring is to be used for the automobile, okay, and subjected to a 4500 Newton load. So single load is given, so again it is static approach with a corresponding deflection of 65 mm. Y is given, so P is given, Y is given. The spring is to be operated over 50 mm diameter rod. Diameter of the rod over spring is operated is 50 meter. What does it mean? Let's get, this is a spring, okay, this is a having coil like spring, okay. So its inside diameter should operate on 50 mm rod. So that 50 mm rod should be less than this inside diameter. So inside diameter of the spring should be more than 50 mm. Alright. Decide the diameter of the wire. Okay, small d. Number of active turns N. Free length L. F. Make sure that the spring is safe for solid stress. Find solid stress. What is solid stress? That we will see. Calculate the pitch angle. That also we will see. This is Newton. For material spring, SU is equal to some relation is given. This is nothing but ultimate stress, yield stress, and modulus of rigidity. So sometimes it is given as capital DW like that terms. So it is nothing but diameter of wire only. So small diameter. That is relation is given. And one more point is given. The maximum number of application of the max force is expected to be 10⁵ cycles. Okay. So G is given and number of cycles is 10⁵, and this term is also given. Now which term we have to use? Okay, first we will select what is this number of cycle. Okay, according to that number of cycle we have to select the diameter of wire. Okay, we will see how to select. Now first one is diameter of wire. Now see, what is given is number of cycle 10⁵. So I have already told in last sum, when number of cycle is given, you should go to the PSG 7.102 and find the recommended design stress. Okay, number of phi number of cycle is 10 raised to 5, so it is lying between 10 raised to 4 to 10 raised to 6 here. So it is average service, and tau permissible is 0.324 sigma u. Okay, so from PSG 7.102, tau permissible is equal to 0.324 sigma u. Alright, now what is this term exactly? It is nothing but sigma u. So number of terms are given. So for our use, it is only this term. So we can find this. Okay, I'm just putting sigma permissible is equal to 0.324, and that term, that is 1996 divided by 0.168. Alright, so I'm just doing the multiplication, and you will get the value of, after multiplication you will get value of 646.7 divided by d raised to 0.168. Okay, so this is tau design, or so this is not sigma, it is tau permissible. Okay, permissible shear stress, right? So you can say tau permissible or tau design, that is same. Alright, now we are using static approach. Again we are having static approach, and we know the formula. We know the formula from PSG 7.101 So tau is nothing but, for static approach you can use this formula. Okay, so but tau is equal to k sh. Don't have to use ks because it is static approach, so we should go for shear stress factor 8 pc divided by pi d square. Now value of c is not given, so you have to assume it between 4 to 12. Okay, now I'm assuming value c as, you can use assume any, I'm assuming c is equal to 5. Okay, I'm assuming c is equal to 5. You can use 6, 7, whatever one, but usually try to use 5 or 6. Okay, now what is k sh is equal to 1 plus 0.5 divided by c. So it is nothing but 1 plus 0.5 divided by 5. So it is nothing but 1.1. So now you're having ksh value, you know the p value, you know the c value. Okay, I'm just putting this term over here. So now, and tau value is, tau permissible value is this term. Okay, so I'm just doing tau permissible. Okay, so tau is equal to ksh is 1.1 into 8 into p is given as 4500, c is 5 whole divided by pi into d square. So I'm having this value over here, and tau permissible is, now you can say that tau permissible is nothing but tau permissible and tau, the relation between tau permissible and tau. So this tau should be equal to or less than tau permissible. So I'm just using this equal to sign, and I am finding the value of t. Okay, so now tau permissible should be equal to tau, actually it is tau permissible should be equal to or less than greater than tau. Okay, now I'm having term tau permissible as 646, I think 7 upon d raised to 0.168, yeah, is equal to 1.1 into 8 into 4500 into 5 upon pi into d square. So now you can use the solve for x equation, and you can find the value of d. So you will get the value of d as 12.17. Alright, so use the PSG and find the required diameter, that is standard diameter. Okay, now we having value of 12.17. so see 12.17, so 12.17 is here, so 12.17 is there, so you will take 12.5 as a value. Okay, so D is equal to 12.5. okay, just mention it. PSG 7.105. okay, so now we got the value of D. okay, so we should go for we should calculate the value of capital D. okay, so mean dia capital D, we know that C is equal to D by small d, so capital D is C is 5 into 12.5, so it is something 62.5 mm. right. okay, so we have one diagram over here, simple helical spring diagram. We found out the value of T. There is one condition, if you remember, the value of the rod on which spring is operated having diameter of 50 mm. So this inside diameter should be more than 50 mm. So we have to calculate this. So what is the inside diameter now? Inside diameter of spring di will be equal to D minus, see D is a mean diameter, so mean diameter means it is center, from this center to this center, so we have to minus this and this, so it is nothing but half D, so D by 2, we can say D, so D minus D, so it is 62.5 minus 12.5, it is something 50 mm. So inside diameter is 50 mm and spring has to operate on the 50 mm. So now spring can't operate on 50 mm dia. Spring can't operate on 50 mm dia rod. Okay, this inside diameter is di. Okay. So we have to increase the size of the wire. Okay, so it was 12.5, so next is 13, so we selected 13, so increasing wire dia, so D is equal to 13 mm from PSG, .105. So now D is equal to 13. So what is capital D? So capital D will be 5 into 13. So it is 65 mm. Right. And what will be the DI? DI will be capital D minus small d. That is 52 mm. So if it is 52 mm and it is 50 mm. So inside diameter is 52 mm. There will be 1 mm gap over here, 1 mm gap over here. So we can say that DI is greater than rod diameter, hence it is accepted, okay, or adequate. Okay, so accepted or adequate you can write. Okay, so now we fulfill the condition, so we can move the for next step. Okay, next is calculation of active turns. So calculation of active turns, we know the formula, we have to go to PSG 7.100 and we have to use the formula of Y. This formula, you can use any formula and you just find out the answer of N. Okay, Y is given as maximum deflection 65 mm. Okay, so formula of Y, so Y is equal to 8 P D cube N upon pi D, so G, this is G D raised to 4, right? PSG 7.100. So what is Y? 65 is equal to 8 into P is given as 4500 into D is something we got 65 cube, number of turn we have to find, upon G is given as 79350 into D we found out as 13 raised to 4. So from this N can be calculated as 14.9. So you can say 15 tons. Alright, so you got N. So we know which type of end we select. So it is square and ground from PSG 7.101. So selecting square and ground end. So N dash is equal to N plus 2. N dash is nothing but total turns. Total turns. Okay. N dash is total turns. N plus 2. What this is means it is having N active turns as N and 2 which are inactive, which are going to sit on or going to, so these 2 turns or 2 coils will be in touch with the base, so they are inactive. Okay, and these are active turns from PSG 7.101. Okay, so N dash is 17 tons. So we got N dash. Now we can go for solid length and full length. Okay, free length. So let's start with solid length. Solid length, LS. We know the formula. LS is equal to D into N plus 2 into D. From where? Again PSG 7.101, same table. One more time I will show you the table. So same table from PSG 7.101, square and ground nut, solid length dn plus 2d, and free length pn plus 2d, pn plus 2d, dn plus 2d. Alright. So what is diameter D is 13. What is number of turn? I think 15 plus 2 into 13. So it is something 221 mm. Alright, so we having LS. Now we can find free length. Okay, so free length LF. So we have seen in the last problem formula for LF. So LF is LS plus Y plus 0.15 Y. This is not given in PSG. You have to remember this. This is 221 plus 65 plus 0.15 into 65. So you have to calculate. So it is 295.75 mm. So now we are having free length, but LF is equal to P into N plus 2 into D. Again, this is from same page of 7.101. Beside this formula, you will get this formula. Beside this formula, you will get this formula. Okay. So, what is value of LF? 295.75. Pitch we want to find N 15 plus 2 into 13. From here you will get N value as P value as 17.98. Next is to find helix angle. Last term they have asked in question. So helix angle phi is tan inverse pitch upon pi t, with nothing but tan inverse pitch is 17.98 and pi into 60.65. So it is nothing but 5.03 degree. So we are done with the second problem. So I think it was little lengthy, but it was asked for 15 marks, so it is worthy. Okay, so I think 1 or 2 terms new, otherwise it was same like previous problem. In next video we will go for dynamic condition, that is fluctuating loading. Thank you for watching the video. Hopefully you are understood both the sum. Okay, share, like, subscribe. Thank you.